24.4 is called First discovery. First discoveries. So what he hooked up is something like this. Fully charged capacitor initially. This is a C, and he charged with the Q maximum. So if you remember Q max, your C times V, and then we fully charge. And then after this, he hooked up a inductance. Inductance, but nothing is a wire coil like that. If we fully charge the coil, then this thing is going to discharge. All the energy will flow and store in this inductance. When this inductance is fully charged, and then the capacitor charge is no more energy. So that in this case, this one going back, in which case it's oscillating back and forth, they call LC circuit. LC circuit is related with what we call antenna design. So if you do this, this thing is in here, then you got a circuit, in which case is Q divided by C is the voltage. Voltage from here. And then you got another one is called closed loop, is a plus L d I dt, in which case equal to 0. The closed circuit equals 0. So now he would like to prove that this is the case with the oscillation function. So what is I? I equal to dq dt. So if you do the very simple math, then you have a d2q dt 2. That equal to minus Q maximum divided by C and divided by L. So if you've done this per se, what does this function represent? If you look it up for the oscillation circuit, the oscillation spring, what the spring has, d2x dt2 are equal to minus k divided by mx. So LC is turned out to be related to this omega square. So 1 over LC is a relationship to the LC oscillating circuit. So, so the oscillating circuit say the omega is equal to 1 over LC. 1 over omega square equal to LC. So this is the omega square. So in comparatively speaking, that's what you got. So he did the experiment and did the experiment very well and proved it existing. It has very nice diagram on page 817. Please take a look at this and do that. Okay. Okay. Today we continue on chapter 24. 24 is on EM waves. Right now we're talking about the energy for the EM wave propagation. Basically, EM wave with oscillation like this, basically is almost like what we call the spring oscillation. When it is spring oscillate, it has energy. So do when the electrical field and magnetic field oscillation, it does carry some energy. And that particular energy is related with the Poynting vector we classify. When the Poynting vector, we calculating the energy for the electromagnetic wave is S equal to 1 over mu sub 0 electrical field cross product of magnetic field. In which case, if this electrical field is perpendicular to magnetic field, usually the electrical field and magnetic field are perpendicular. So if it is perpendicular, and E cross B equal to E times B times sine theta times sine theta. Sine theta is 90 degrees, so consequently equal E times B 1 over mu sub 0. And the unit for the energy is watt per meter squared. Watt per meter squared. So now, since this cross is cross product, so you should relate it with E times B times sine theta. So the electrical field and magnetic field has certain relationship, as we presented before. The magnetic field equal to 1 over C times E. By using this, then we substitute back in this relationship, then we get S, the absolute value of the energy here is equal to E squared divided by mu sub 0 C, or C divided by mu sub 0 times B squared. This is the electromagnetic wave carrying energies. So if we're oscillating, the electrical field oscillating up and down, and the Poynting vector energy is E squared, so it's this vector. But the E squared consequently is related with the energy called electrical energy average. We have to do the integral over a period. Means 0 to 2 pi. In which cases the E average is equal to square root E2 and then divide that by E max. This is the E average. And B average equal B max divided by square root 2. Using this relationship, we got E square max divided by 2 mu sub 0 C and equal to C divided by B square max divided by 2 mu sub 0. From previous chapter, on chapter 20, we have the electrical field energy oscillating is equal to 1 over 2 epsilon sub 0 E squared. That basically equal to U sub B, now we call magnetic field energy. So U sub B equal B squared divided by 2 mu sub 0, and basically